I bet you have wondered about the gambler's fallacy. It is one of those fascinating quirks of human psychology that makes us believe things about chance that simply are not true. We are talking about a phenomenon that tricks our brains into seeing patterns where none exist, influencing everything from casino tables to everyday decisions. Today, we are going to dive deep into what it is, why it is so pervasive, and how you can spot it in the wild. Let us begin with the classic thought experiment. Imagine you are flipping a perfectly fair coin. You have just flipped it 99 times in a row, and every single time it has landed on heads. Pretty wild, right? Now, you are about to make the 100th flip. What do you think the chances are that it will land on tails this time? Many people would immediately say it has to be tails, or tails is definitely overdue. This gut feeling is the core of the gambler's fallacy. It suggests that the coin, or the universe, somehow remembers the previous outcomes and tries to balance things out. But here is the cool part. That is not how independent events work. The key is understanding that each coin flip is an entirely independent event. What happened on the first flip does not influence the second, and what happened on the 99th flip does not influence the 100th. Think about it. A coin has no memory. It does not know it has landed on heads 99 times. It is just a piece of metal tumbling through the air. The probability of a fair coin landing on heads is always 50, and the probability of it landing on tails is always 50. This does not change, regardless of how many times it has landed on heads before. So, for that 100th flip, the chance of tails is still exactly 50-50. It is like starting fresh every single time. This leads to the core definition of the gambler's fallacy. It is the mistaken belief that past events influence future independent events in random sequences. People tend to believe that if something has happened more frequently than normal in the short term, it is less likely to happen again, or vice versa. What is fascinating is how our brains crave patterns. We are wired to look for order even in randomness. When we see a long streak of heads, our pattern-seeking brain screams, "This cannot be random. Something has to change." But for truly random, independent events, a streak is just a streak. Now, here is a crucial distinction. While the 100th flip is still 50-50, the probability of getting 100 heads in a row before you start flipping is astronomically low. It is 12 full hundred, which is an incredibly tiny number. This is where the confusion often lies. To understand this, consider asking, what is the chance of 100 heads in a row? Is different from asking, given 99 heads, what is the chance of the next flip being heads? The first question refers to a series of future events, while the second refers to a single future event given known past events. The foundation is the law of large numbers. This law states that as you repeat an experiment like flipping a coin a very large number of times, the observed frequency of an event like heads will converge on its true probability, 50. But people often misinterpret this. They think the law of large numbers applies to short-term sequences, forcing a balancing act after a streak. It does not. The law only guarantees convergence over an extremely long run, not that individual events will immediately correct past deviations. Let us examine a real-world example, the roulette wheel. Imagine the ball has landed on red 5 times in a row. Many gamblers will flock to black, believing it is due. They feel the odds have shifted in favor of black to compensate for the recent reds. Continuing on, the roulette wheel, like the coin, has no memory. Each spin is independent. The probability of landing on black or red, or green for that matter, remains constant with every single spin, regardless of the previous 5, 10, or even 50 outcomes. What becomes clear is that this fallacy is not confined to casinos. You see it in sports, too. A basketball player might hit 5 shots in a row, leading commentators to say they are hot and will likely keep scoring. Conversely, after 5 misses, they might say the player is cold and due for a basket. Evolving from that, while a player's skill can influence overall probability, individual shots are still highly independent. A string of successes or failures is often just variance, not a magical shift in their underlying ability for the next shot. Assuming a hot hand or a cold streak will continue or reverse is falling into the same trap. Consider how this plays out in financial markets. Investors might see a stock price rise for several days and assume it is due for a correction, or fall for several days and believe it is due to bounce back. While market forces are complex, the fallacy often oversimplifies individual price movements. Adding to that, the due for a correction mindset can lead to poor investment decisions, causing people to sell too early or buy too late, based on a flawed understanding of short-term market randomness. Market trends exist, but individual fluctuations often are not due for anything in the gambler's fallacy sense. What we discover is that our brains are incredibly good at finding patterns, even where none exist. This cognitive bias, called apophenia, makes us perceive meaningful connections between unrelated things. A long streak of heads feels significant, so we invent a reason for it to change. Our desire for control also plays a part. In a truly random world, we have no control. Believing that a pattern must emerge, or that outcomes must balance out, gives us a false sense of predictability and agency over chaotic events. It is a comforting illusion. Here is where it all comes together. It is vital to distinguish between independent events and dependent events. The gambler's fallacy only applies to independent events. Dependent events, however, do change probabilities based on previous outcomes. An obvious example of dependent events is drawing cards from a deck without replacement. If you draw an ace of spades, the probability of drawing another ace changes because there are fewer aces and fewer cards overall left in the deck. The past does influence the future here. This is also why card counting in blackjack works. A card counter tracks the ratio of high cards to low cards remaining in the shoe. As more low cards are dealt, the probability of high cards appearing increases, shifting the odds in the player's favor. This is not a fallacy, it is smart probability. So, the key is to always ask yourself, are these events truly independent? Does the mechanism generating the outcome have any memory, or is it influenced by past results? For dice rolls, coin flips, or roulette spins, the answer is almost always no. The process begins by recognizing that our brains are prone to these errors. Once you are aware of the gambler's fallacy, you can start to identify it in your own thinking and in the claims of others. It empowers you to make more rational decisions. Taking the next step, it helps in avoiding scams or poor investments. If someone tells you a lottery number is due to win, or a stock is due for a rebound simply because it has been down, you will recognize that as the fallacy at play and stick to evidence-based reasoning. Where we land is the realization that true randomness is often counterintuitive to our brains. Long streaks happen. Short streaks happen. It is all part of the probabilistic landscape. Accepting this helps us navigate uncertainty with a clearer mind. To put it simply, do not let your brain trick you into seeing patterns where there are none. Each independent event truly is a fresh start. The coin has no memory, the dice have no history, and the roulette wheel does not care what happened last. The most important part to remember is the difference between the probability of a sequence occurring before it starts and the probability of a single event within an already started sequence. The latter is unaffected by prior independent outcomes. The takeaway? Next time you see a long streak of identical outcomes in a truly random process, resist that urge to bet against it because it is due. Embrace the randomness. Understanding the gambler's fallacy is a powerful tool for rational thought in a world full of chance.